Okay, good morning. Right now, I will give you the revision on lecture 3, which is projectile motion and also some other motion. Basically, in this lecture, we cover, first is displacement, or sometimes distance, it depends whether it's vector or scalar quantity. So displacement is, maybe I put it as d or s, up to you, and velocity, which is v, and the last thing, which is acceleration. And for acceleration, a, let's say. So, before this, what you have learned in the SPS, also in foundation, we focus on 2 or even 3 scenarios. First is when v is constant. Second is when a is constant. And the third column or the third scenario, which is nothing is constant. So this one, no constant at all. So basically, especially in SPM, you have studied, if let's say v is constant, then we can use the only formula, which is displacement equal to velocity times time. On the other hand, I can also say velocity is displacement divided by time. Okay, so this one is only for when we use certain cases v is constant. On the other hand, if a is constant, you can use all those kinematic equations about the kinematic study. So the one we involve several equations such as s equal to ut plus half at squared, v squared equal to u squared plus 2as, v equal to u plus at, and so on. Basically, we have about 5 equations to support this kinematic study. And the last one, which is no constant, which means that maybe I said that the displacement is, let's say, exponential to the power of minus t. From here you can see that it shouldn't be, there's no any variable that is constant. No constant variable at all. So that for this case, we must use v equals to, let's say, dx over dt. And the x is actually displacement. Bear in mind, before this, I put d as a displacement, but to make it clear, here I put it as x. On the other hand, the acceleration is just dv over dt. So, it's also differentiation. In order to get back, let's say, I want to get the value of v if a is given. Then we use integration. For the integration, basically, it's also the same thing. V is just integration of a dt. It depends whether it's a vector or we consider non-vector. On the other hand, so I can write this one to make it clear. On the other hand, s equal to v dt. So it's just a different symbol, but basically it indicates either displacement or distance. And by using this one, we can proceed with some questions. And in your syllabus, most of the time, it is related to projectile. A projectile, the best example is angry bird. So let's say there is an angry bird, or maybe you want to throw something. Okay, you might throw it horizontally like this. You may throw it at a certain degree like this, or maybe throw it down like this with a certain degree or angle. So on the other hand, you may directly throw it upward or downward. Okay, I will discuss one by one to support the projectile. Okay, the first thing, let us take a look on this part, which is the vertical projectile. So for vertical projectile, it's quite easy. Basically, you should know that all this one, the vertical projectile, it is linked to gravitational acceleration, denoted by g. And normally we say that g is 9.80 meter per second squared. So for this case, you need to justify whether it is positive or negative. So for me, and most of the time in some lecture and also the reference book, we will say that the acceleration is negative 9.8 meter per second squared. As because the negative indicates downward. Negative indicate downward. So if the A is negative 9, so I give you an example. If I say I throw something up, okay, I throw up, an object is thrown up, then with the initial speed of uy is 2 meters per second. So I ask you, what is the displacement after 5 seconds? Let's say something like this. So you can use y equal to uyt plus half at squared. That is the concept. So if let's say I simply say is what is the displacement after 5 seconds, then you can substitute, which is y equal to this one, the positive indicates upward, so I can put it as positive 2.0 5 seconds plus half negative 9.8 5 square. Okay, negative again indicate downward and positive indicate upward. So as a result, you can get the y. Okay, and a good example here is that, as I said, all we deal for this case is only A is a constant value, which is either positive 9.8 or negative 9.8. So which means that for this case, you can use kinematic equation to solve the problem, to find out the solution. So kinematic equations are very useful, are very important for this kind of question. So let me go to the second one, or even the third one. That means that either you can throw it down or upward or horizontally. For example, a simple example first. If I throw it horizontally like this, initially there's a V at here, which is, I don't know, I just simply put maybe 3.0 meters per second. So, to make it clear, we have two types of, we can resolve it into two parts. One is the x-axis or x direction, another one is the y direction. And logical thinking, by right, this one, the path or projectile path should be something like this. It's a curve like this. So basically, there's still, so all the time you can see that, let's say maybe this one I put it as V0 to make it clear. V1 at here, V2 at here, V3 at here. You can see that all the time it has different value, different angle. And this one is due to the y component. So the first thing I would like to remind you all, when we do a projectile, maybe I throw a bird, angry bird let's say, I throw a ball playing the basketball, or else I kick the football, let's say. So no matter how, we can split it into two components. For the x direction component, or x component, sorry, Vx is constant. So from just now, what did I mention was, when the V is constant, we can use Vx equal to x divided by t. So which is also the horizontal displacement is just Vxt. And this Vx is also V0xt, where V0x means the x component of initial speed. So for example, for this case, V0x is actually V0, which is 3.0 meters per second t. Okay. Maybe you will ask, how about the y component? So V0y is 0 because initially there is no any vertical component for the speed. So as a result, V0y is 0. So maybe I give you a scenario at here. Let's say a ball is thrown horizontally at the speed of 3.0 meters per second. And maybe I will ask you, after 5 seconds, what is the vertical component? What is the horizontal component of the displacement? This is a simple example. So, if like that, I can say that V is Vxt. Okay? It just depends. How do you find out? Let's say if I simply say the time is 2 seconds, 3 seconds, 4 seconds, same thing. You just substitute 3.0. They say I simply say is the time is 2 seconds. So which means it's 6 meters. This 6 meters indicates the horizontal displacement. And how about the y? So we use the y equal to v naught yt plus half at squared to make our life easy. Downward we use negative, upward we use positive. And as I said, for this question or this scenario, this is 0. V naught y is 0 because initially there's no vertical speed. So 0 plus half minus or negative 9.80 time, let's say is 2 seconds, so 2.0 squared. So you will get a negative value, and this negative value indicates the displacement is, the direction is downward. So it's logical with a qualitative statement like this. So when you want to answer this one, a conclusion I can make is all the time for the x direction or x component, v is fixed. When v is fixed, we can say that Vx equal to V naught x equal to certain value. Somehow, you need to use this equation, which is the x displacement is Vxt, which is also equal to V naught xt, up to you. On the other hand, for the y component, because there's a fixed acceleration, which is the gravitational acceleration, negative 9.8. So, you can use all those kinematic equation to support. Let me move to the third case of the scenario. If I simply throw one ball, maybe upward or downward, with a certain angle, let's say like this, let's say 20 degree or 30 degree, maybe I put it 30 degree like this. So I say that the V naught here is 2.00 meter per second. So for this case, the V naught here, as I said, you can always split into x and y components. Split them into x and y component, and logical thinking, you know that the path is something like this. So at this moment, we split into V naught x here and V naught y here. So for the V naught x here, then V naught x is V naught cos theta, which is actually 2 cos 30 degree. So this is something you have done before this, and what else? On the other hand, V naught y is, you should know that this one, the direction is upward, so we can use a positive. So positive V naught sine theta, which is positive 2 sine 30. So my question is also very easy. What is the total displacement in terms of an x component and y component after, let's say, 2 seconds? So the same thing you can make here, which is you resolve it into 2 components and then per component basis. So for the x component, we know that x equal to Vst. Let's say t is 2 seconds. So Vs is actually also Vos t. So which is V naught cos theta t. I put a bracket here to make sure that this formula is not so ambiguous, because somehow people may think that if you just write it as V naught cos theta t, some may be confused whether it's cos in bracket theta t or cos theta t. To avoid this kind of ambiguous statement or scenario or phenomenon, we try to put the bracket like this. So for this case, we know x cos theta is exactly the same as this one, which is 2 cos 30, and the time, let's say, is 2, we put it. So what is the answer? On the other hand, for the y component, is V naught yt plus half at squared. So right now we have the value. V naught y has a value, so which is plus 2 sine 30. That is V naught y. Times the time, let's say it's 2 seconds, then plus half negative 9.8, 2 to the power of 2. So what is the answer? And for this y, if you get a positive answer, let's say, if in one scenario or one case study, the y, the value of y, let's say is plus 10 meter. That means actually meter. Okay. From the reference you go out, then this is plus y. If let's say there's another case whereby the y is negative 20 meter, let's say, so that you continue to get it from the reference going down, which is negative 20 meter, and here is the corresponding displacement, which is negative 20 meter. So that's why projectile is about acceleration, is about velocity, is about displacement, and all three variables are vector. Direction is very important. So maybe I can give you some other example, which is help you. So let's say I give one example. Okay, on top of a building, I throw a stone here, and the speed, initial speed is, again, let me simply put 2.00 meter per second, and the angle is about 30 degrees at this. So my question is, what is the displacement when the stone at the highest position, or so-called the maximum height? Okay, so in order to get the maximum height, and here maybe I define this as x, this as y. So we try to analyze this question. So maximum height at maximum height or maximum or highest position, you should know that Vy is 0. Take care here, Vs is not 0. Because why? All the time Vs is constant. Even at this point there is Vs, but no Vy. So Vy is 0, then maybe you can continue to use Vy squared equal to V naught y squared plus 2ay, compared to so-called the V squared equal to u squared plus 2as. So these two are equivalent. Then we proceed. So for this question, the Vy, as I said, is 0. So 0 equal to 2 square, sorry, it should be 2 sine 30 square plus 2 minus 9.8 y. So what is the y? Okay, from that you can find out y. And also, whereas for the x, you can try to imagine the x is still the same thing, which is x equal to vxt, which is v naught cos theta t, which is 2 cos 30 t. But the problem is, what is t? In order to get the value of t, you may start from here. Because you have calculated the value of y, you can try to use y equal to v naught y t plus half at squared. So this case is 2 sine 30 t plus half a, which is actually negative 9.80 t squared. So by right, you know the value of y already, you substitute, and this one you can use your calculator to find out the quadratic equation. So from that, you can find out what is t. And this t, you can substitute to this part. So as a result, you can get the value of x. The value of y, no problem. So this is something like the analysis on this kind of the question. And maybe I can proceed with some other question for the projectile. How about if you throw down? You throw down something from a high building, let's say, a stone, let's say, so which is 2 meter per second, and the theta again, let's say the theta is 30 degrees. So how do you do that? The same thing, but right now we split into two, Vox or V0x and V0y. But the problem is V0y is negative V0 sine theta, which is negative 2.00 sine 30. Okay. Why there's a negative? To indicate the direction of V. And normally, as I say, we all consider downward is negative, outward is positive. So as a result, V0y is negative 2 sine 30. So how about some other analysis? Should be the same as the previous cases. So the same thing, Vx is still V0s, still V0 cos theta. So the x is still Vst, is still V0 cos theta t. How about the y? Also the same thing, as long as you know that the V0y is a negative value, then you can still substitute accordingly. So one of the good example is something that you have done it in the practical. Let's say this is a cylinder or pipe, okay? Then there's a spring. You put down the spring and you release the ball. So at this moment, there is a U here. Maybe I put it V0y. So it goes up and goes down here. You use the time, let's say the stopwatch, to measure the time at here. So let's say spend 6 seconds from here to the top and go back here. Okay? If for this symmetry question, which means that we can say that from here to here, the time, a single trip, which is t equal to 3 seconds. Because the total time here is 6 seconds, so per single trip from here to the top is 3 seconds. And for these 3 seconds, then we proceed the analysis. So the first thing we can use is, we can think about is V equal to U plus AT. So in this case, which means that V y equal to V0y plus AT. And V0y we don't know, which we remain it. And Vy here, the highest position, Vy here is 0. So it's 0 equal to V0y plus negative 9.8. And let's say the t is 3.0 seconds. So you get the value of V0y. What is the use? The use is, I want you to find out the displacement from the reference here until the maximum height here. So next, let me define this as y. So y equal to V0yt plus half at squared. So t is 3 seconds. So by right you know the value of V0y here. So put it 3 seconds plus half negative 9.80 and 3 seconds squared. So we can get the value of y. So these are all about the analysis on projectile, whether it is throwing upward or downward, that means vertical, and then whether it is thrown horizontally or else there's a certain angle respective to the horizontal position or direction. And the last part that I would like to discuss with you is on the non-constant variable. So if the A is not constant, V is not constant, of course, so that you can only use the acceleration, the differentiation. So let me give you an example. I say that there's a car, let's say, move at a displacement of x equal to e to the power of t, let's say. So from here, this one, you can differentiate v equal to dx over dt. And for this case, coincidentally, it's still e to the power of t. On the other hand, a equal to dv over dt is also e to the power of t. So from that, you can find out the value accordingly. Let's say I give you a practical example. If there's a case I say that x equal to t squared, and I ask you what is the velocity or speed after 2 seconds. So when t equal to 2 seconds, v equal to dx over dt, which is 2t. Bear in mind, t squared, you differentiate t squared, you get 2t. Okay? Last time in the exam or test, student made careless mistake whereby he think that dx over dt means s over t. So s is t squared over t. So answer is t. This one totally wrong. Please refer back to this differentiation. So let's say dx over dt is 2t, which is 2, so it's 4 meter per second. That means at that moment, when the time is 2 seconds, the velocity is 4 meter per second. Vice versa. If I give you the value of v, I ask you to find out the value of x, you can use that accordingly. So basically, this is something about lecture 3, projectile, and also all those are 3 important variables. Okay, thank you.